All right, so we just made it out to Long Island on this beautiful summer day. We're here at the Addario. We're gonna go inside, take a look, get our passes, and see what we can get into. Let's check it out. So Jim D'Addario just walked us over to the string factory. We're gonna walk around and take a look. Should be really cool.
In this building, we manufacture our Evans drum heads, and we also manufacture all the high carbon steel that we use for the plain strings in our steel string sets, and all the hexagon shaped core wire that we wind the wound strings onto. So
awesome.
A very critical, difficult product to make, high carbon steel. It's a very hard temper wire, and if you overdraw it or overprocess it, it becomes brittle. If it's not hard enough, it ends up becoming, it won't stay in tune as well.
Okay.
In the past, we were at the reliance of various vendors, and we also had this tiny company in Massachusetts, but it was being run remotely. Equipment was old, and in 2013, we decided to redefine the manufacture of music steel wire. And we studied the whole process with consultants and engineers. We ended up settling on a machine designed from Germany for the drawing of the wire from a thicker rod that we buy down to the fine sizes and the shapes that go into a string. And it's very critical to getting a great string. Wow. And we defined the whole process. We ended up buying 4 drawing machines, completely re-engineering the coating of the wire, the tin, and we took what was a product that, generally speaking, when we received it into inventory here, we would reject 20 to 30% of it. We took it to a point where we reject virtually nothing.
That's awesome.
And we, along the way, discovered how to make a stronger, better steel that stays in tune longer without having to retune, and that became MYXL, which is our premium set of strings, which is now 25% of our electric string sales.
Wow.
And I know our customers love the product. It keeps growing every year, and we would have never been able to engineer that relying on outside vendors, because they're so busy making millions of pounds of wire for the spring industry, for automotive. And the little bit that our industry uses isn't enough for them to justify the engineering, and they just don't pay attention to us. Right. So we had to do it ourselves, and that's what you're going to see here.
That's incredible.
Really cool story.
All right, let's take a look.
We're standing in the area where the raw material that we're going to make the plain strings and the hex cores is received in inventory. And the wire comes in. You could see here how thick it is. This wire is about 1/16 of an inch in diameter. You don't have any string on your guitar that thick, right?
Yeah, absolutely.
So we will draw this wire down to as small as 3.5 thousandths for a violin string core.
That's cool.
Right? We start with a wire that's actually created for the automotive industry. It's the same wire that goes in a steel belted radial tire.
That's cool.
And what they do is they draw it down just like we do, and then they put it into a cable form. It's a very fine stranded cable that goes in the tires. And we make the same kind of cable for our helicore violin strings, right? From this material.
Wow.
But what we do is we source an aerospace grade, the highest quality, highest grain structure, finest grain structure, the highest quality you can get. And we have very stringent specifications. And this is what made it possible for us to develop MYXL. And that stronger steel and that stays in tune longer.
That's very
so
cool.
This wire comes in on these reels that are like a couple of tons.
Wow.
And they go through drawing machines, which are a series of metal dies that incrementally reduce the diameter and of course make the wire much longer. If you think of chewing gum, when you pull it, it gets thin and it gets long. Well, we're pulling it through dies that are progressively making the wire smaller and smaller. These machines can have up to 20 dies running. So this wire is probably going down to a 15 thousandths or a 14 thousandths hex wire. So this machine we're going to show you running, I can't open it because the coolant would spill all over us and we'd get dirty. But I could show you the wire coming out the back end, and then we'll take a look at that machine that is open, and you can see what's going on in there. It's
awesome.
It's quite complex.
That'd be great.
And the engineering that went into these machines, we didn't build these machines, but we specified them to what we needed to make the best product, and we bought a whole fleet of them. We have 4 for high carbon steel and 1 for phosphor bronze now. So anyway, let's go and look at what's going on here. Here we got this 60 thousandths of an inch diameter wire going into the drawing process. And here it is going onto the spool as 013 hexagon shaped wire.
That's amazing.
That'll be used for like an 026 or an 024 wound string, right?
Right.
So it's a pretty fine diameter. And the reason we use a hex shape is when we wind on that as a core, those corners bite into the wire and make a better bond between the wrap wire and the core. And if the machine is running and the dies are getting very hot and as they start to wear out, that shape will start to melt away, kind of, right?
Okay.
And you can have wire that's marginally good. And the strings could be okay, they could be not okay. Previous suppliers, and unfortunately what a lot of our competitors are subject to, is buying wire that is not made to the same kind of standards where we're making our wire to. So for instance, we check this hex shape, every single spool on a laser system that we developed to make sure that every corner is perfect. And as soon as we get a spool where it's still great but not perfect, we stop, we change the die, right? So we could take this 013 die and make an 014 die out of it, right? And reuse it. Perfect. Not a big problem for us.
Sure.
We know we're gonna use it. But we stop making the wire before it even comes close to being marginal. Right. So I'll show you that over here. It's interesting. Picture the shape of a nut, right? It's hexagon shaped, right? You put a wrench on, it's pretty big.
Right.
Now you're talking about small wires that are 13 thousandths, even down to 10 thousandths hex.
That's
very
amazing.
tiny shape, right? So measuring it is critical. So what we did here is we developed a system. You can see how this is rotating around. We take a piece of the wire off of every spool we draw, and we rotate that around and measure it, I believe, at every 5 degrees. And then that's fed into this machine here, that these 2 red lines are the accepted tolerance for that corner that they're measuring. And you'll see the 6 corners, and if they fall within this incredibly tight window of tolerance, then that wire is good enough for our strings.
Wow.
And if it as soon as it gets close to these red lines, machine stops, we change the die.
That's amazing.
We get absolutely perfect
How
hex
cool
wire.
Is that?
That's why our strings, even if they're not coated, they last longer. They're brighter sounding longer because the wrap wire bond is being held by these really sharp corners better. It's critical, you know. It really is critical.
That's
so
amazing.
this runs. We use this. We test every spool we make.
Yeah.
So we take you over here and you see inside one of the drawing machines.
Now, Jim, I've never noticed this with a D'Addario string, and I won't name any other brands, but every once in a while you get a pack of strings and one of them has a dud in it.
Yeah.
Does this process kind of prevent that?
Exactly.
Okay, so no dud.
There's 2 things that would make that dead string. If they're using hex wire and the hex isn't the right shape, the wrap wire will be loose, right? And it's going to be dead sounding. The other thing that's really mission critical, and I'll show you when we get over to winding, the tension that you put on that wrap wire as you're winding the string. My grandfather used to do it by hand and my father by hand. It's nice, you can get some good strings, but you don't get them all day long, right? That tension has to be quite strong and a precise amount of tension to stretch the wire a little and make it adhere to that core. And if somebody sets a machine up wrong, or they're winding a string by hand and it's the end of the day and they're tired, they're just laying wire on a string and you're getting a dud.
Yeah.
It's no good. Yeah. So we've designed all of our machinery, you'll see in the other building, so that there's these computer closed loop system that's measuring with a load cell what that tension is and constantly correcting it. So it's very hard for us to make a bad string.
That's awesome. Very cool.
Here's another thing we're really proud of. You know, our phosphor bronze strings were the first on the market, and we were always at the mercy of buying phosphor bronze wire from various vendors. Now we make it here, and we make it to a tolerance that is quite unbelievable, actually. So here today we're making 009 phosphor bronze wire. That's going to be used on a D string, like 032s to 036 in that range. And the way we start, and if you can get a shot of this laser micrometer here, we will start with, you notice we're not making 9,000ths, we're making 8.95, right? So this is 1,000th of an inch, this decimal. This is a 10,000th of an inch.
Wow.
This is 100,000th of an inch,
Wow.
right? As soon as this number, we'll start off with it a 5/100,000 smaller.
Okay.
And as the die wears out, that wire will get slightly bigger, right? As soon as it goes to 00905, 5/100,000ths bigger, we change the die.
Okay.
So when somebody like Joe Satriani or Pat Metheny gets a hold of a set of strings, if I make it, if I accepted that wire to be 8.2, for instance, instead of so precise, they would notice a different tension, right?
Yeah.
So it's critical to us. You see, it's on the teetering right now, going to 9 almost,
Yeah,
right?
just switch
But
that.
we watch these tolerances so tightly and make sure that the wires we're making are so perfect
Right.
that we're going to make a consistent tension, a consistent string, one time after the other.
Amazing
Really-
attention to detail.
Yeah,
That's incredible.
attention to detail, and it's a high level of passion for perfection.
High level of integrity. You
Yeah.
know, it's amazing.
So, I mean, that's what we try to do at all our factories, whether it's the Reeds in California or Drumsticks in Houston, all made the same way.
That's great.
Yeah.
Incredible.
Coming up, we sit down with Jim to talk about the historic D'Addario family, the music accessory business, and a whole lot more. Check it out.